Good morning and Assalamu alaikum. Since in our previous lecture we were discussing about what was discussed as hydrocarbons, and in hydrocarbons we were from alkanes, we were generating alkyls. Actually, alkanes have general formula CnH2n plus 2. That means it's CH4, the primer or first hydrocarbon, the simplest hydrocarbon, what's called as methane. Since this we know in our previous lecture. Similarly, there is the number second, C2H6. This is ethane. And the number third, it was C3H8, and that's propane. And in the similar sense, this is butane, CA4H10. And this is butane, and this is C5H12. This is pentane. And similarly, we can proceed up to number 10, but we don't require here. We can generate from these, and we can understand those examples how we generate alkyls. Furthermore, this methane, on eliminating one of the hydrogens from this, I have described this in my previous lecture, that became CH3 single bond, or we can write it two times like CH3 single bond. It's for this purpose because in rest of the hydrocarbons we have to draw two structures. One is the condensed formulae and another one is the what's called as open structures. And this is now here condensed formulae. This is like C2H5 single bond, and similarly this is C3H7 single bond. In the similar sequence, this is C4H9 single bond, and this is another one, C5H11 single bond. I have already discussed these single bonds, how we generate in these formulae, and these are the condensed formulae. Furthermore, we can draw them as this is CH3 single bond, CH2 single bond. In the similar sequence, this will become CH3 single bond CH2 single bond CH2 single bond. In the similar sequence, this will become CH3 single bond CH2 single bond CH2 and single bond CH2 single bond. Then after this will become CH3 single bond CH2 single bond CH2 CH2 single bond CH2 and so on. 1, 2, 3, 4, 5 carbon atoms. Then from butane and pentane, we discussed there arises what's called as isomerism phenomenon. And isomerism furthermore can be discussed like this. I will discuss this. Now the topic is our isomerism, or in other words, these formulas will be called as open structures. Means these things. These will become open structures. Now further, we have to describe what's called as isomerism. Isomerism, we will describe, it is the phenomenon of the molecular formulae with same formulas but different physical and chemical properties. Such as we can take, for example, if there is now butane C4H10, we can draw this in two ways. This is CH3, single bond CH2, single bond CH2, single bond CH3, and this will become, this is called as N-butane, or this is called as normal butane. Similarly, this will become like this, CH3 in two parallel lines, CH3, then after here CH, single bond CH3. This will be called as isobutane. In short, these two formulas will be called as isomers of the same molecular formula. And this will be the isomerism, isomers of the what's called as butane formula. Furthermore, we can discuss these as, similarly for pentane we can take C5H12. This in the same sequence will become CH3, CH2, single bond CH2, single bond CH2, single bond CH3, and this will be called as normal or N-pentane. And CH3, two CH3s in the vertical line, then after combine and join them with CH, then write CH2 and then CH3. Three carbon atoms in the horizontal line and two carbon atoms in the vertical line, and this will become, and this will make, we should say, isopentane. And in the similar sequence there will arise the third isomer of this pentane formula, that's two CH3 molecules in the vertical line and another two CH3 molecules in the another vertical line, and then after combine all these four carbon atoms with the central carbon atom, which will be without any hydrogen, as one carbon atom everywhere forms four single bonds. Therefore this will become another pentane molecule, and that will be, this is called as neopentane. In short, up to 10th class we take examples of isomers of these butane and pentane molecule. Only here these two butane molecules, only these two examples will be taken as isomers of the butane molecule, and these three isomers will be taken as the isomers of the same molecular formula, that's pentane molecule. And why we say this is the phenomenon in which the molecular formula is having the same formulae, but they have different physical and chemical properties. As physical properties are discussed, one of the physical properties, their structures are different, and similarly their melting points and boiling points can also be different. Like for example, for normal butane, boiling point will be higher or melting point will be higher. Melting point, yes, we can say for normal chain, melting point and boiling points will be higher than branched isomer, like this from this isobutane. And here in case of this isomers of pentane, melting points and boiling points of this normal pentane will be higher than what's called as isopentane and neopentane in short. Now from butane molecule, that is C4H10, this is butane, and this can be written, this is the condensed formula, and this can be written also as like CH3, single bond CH2, single bond CH2, and CH3, this is N-butane. Furthermore, we will subtract the hydrogen atom from this. This will become CH3, CH2, single bond CH2, and single bond CH3. Sorry, single bond CH2, and then after single bond, that this will become N-butyl. Like this, we can write here N-butyl. This butane can also be drawn as, since we are discussing in the isomerism formula, how we are subtracting hydrogen atoms and how we are generating alkyls, like here CH3, CH3, CH, single bond CH3. This is isobutane. And when we subtract the hydrogen from this atom, this molecule, this will be generated like CH3, CH3, CH, and CH2 single bond. This will be called as isobutyl. And this isobutane can furthermore subtracted by hydrogen from this carbon atom. When we subtract this hydrogen, this will become like CH3, C, CH3, CH3, and here will generate single bond. This molecule can also be written as like, we will rotate this molecule like this, CH3, CH3, single bond C, then after single bond CH3 and single bond, that is, it will become like this, or sorry, we can draw this like this way, CH3, C, CH3, and CH3 single bond, and this will be called as T-butyl or tertiary butyl molecule. Tertiary butyl molecule means the molecule is having carbon atom without any hydrogen atoms, and which is attached to 3 alkyl groups, so like this CH3, CH3, and this CH3. This is called as T-butyl. Then after furthermore, we will reach to the pentane molecule, as we are generating alkyl molecules in the isomerism or isomers of the molecule. Like for example, for pentane, we'll draw this like this, C5H12, means this is pentane molecule, and this will be furthermore drawn in several ways like this, CH3, single bond CH2, single bond CH2, single bond CH2, and single bond CH3. This is normal pentane, and then we subtract the hydrogen from this like this, CH3, CH2, single bond CH2, single bond CH2, single bond CH2, and single bond, and this will be called as N-pentyl, and this will be called as normal pentane, sorry, N-pentane. And in the another way, this pentane can be represented as like this, CH3, CH3, isopropyl तक तो same representation इसकी आती है. Then after other two carbon atoms in the horizontal line, this will become isopentane. And we will subtract the hydrogen atom from this, and this will become CH3, CH3, CH, single bond CH2, single bond CH2, and then after single bond, and this will be called as isopentyl. And furthermore, this will be drawn like this: CH3, CH3, only single carbon at the center, and then CH3 and CH3. This is called as neopentane. And then after we will subtract the hydrogen atom from this neopentane, and this will become CH3, CH3, C, then CH2 single bond and CH3. This will be again called as any of the, there is no naming for such complex alkyl molecule, but this will be again called as alkyl. And from any of the carbon atoms we will detach one hydrogen atom, and this will become in any way the alkyl molecule. And generally these alkyl molecules are represented by R single bond. R single bond in general means CH3 single bond, CH3 single bond, CH2 single bond, CH3 single bond, CH2 single bond, CH3 CH2 single bond, then CH3 single bond, CH2, then CH2 single bond, CH2, and so on. In general, all these molecules, whether isomers or non-isomers, hydrogen deficit molecules like these molecules, this, and this one, as well these molecules like methyl, ethyl, propyl, butyl, these all are generally represented by alkyl molecules or single bond. Khuda Hafiz and good luck.